So I'm going to take this DNA that we have here, and I'm going to just expand it out. It's GTA, CG, and that's where that ends. So that's our 5' end, our 3' end. And then we have CAT. Like that, and then TAG. Let's make sure those capitalized, shall we? There's our well, okay, so I want to actually take that strand right there. Okay, let's just move it down, like so. Okay, so when we want to design our primers, and in this particular case, we have limited our primer to only 3 nucleotides. We only want to copy the gene of interest, which is shown in red. So our forward primer, we would generate a forward primer based off of the complementary of this strand right there. So what we would have is a CG, ATCG. Oh, whoa, I said only. There we go. So that's our primer. That's going to anneal in that spot right there. So that would be our forward primer. And then on this strand right here, we are going to generate, let's see, CGA. There's that. So what we can say is our forward primer. So let's do it this way. Circle that. That is our forward primer. So the forward primer is bonding to the non-coding strand or the template strand. So this we could say is our template strand. And then our reverse primer, which is this guy, reverse primer is going to anneal to the coding strand. So if we answer our first question, what's the sequence of the forward primer? You would say that is a CGA because we were reading from the 5' to the 3'. What is the reaction or the sequence of the reverse primer? If you wrote it this way, that is wrong because we read DNA sequences from the 5' to the 3' direction. So this would be the correct answer right here. Okay, and that's the reverse primer. So after one cycle, what's going to happen here? Well, if we clean this up a little bit, what's going to happen with the forward primer, it's going to synthesize from here like that. Okay. So what that strand is now going to look like, if we take that whole strand, okay, and let's just come down here, that's going to turn into our CGA, and then TCG, like that, and then it's going to TAG. What is that? That's going to be ATC. Okay, so that is our 5' piece and our 3' piece. And then the 3' piece right here is going to be, you have to expand this out a little bit. Our CAT. And then GCTAGC. Okay, so what's happening here is that the template strand gets converted into this piece, where you will now see that this right here is the gene of interest. Okay, so that strand gives us that molecule, like so. But now our coding strand, okay, this guy, what's that going to turn into? Because we synthesize from the 5' to the 3' direction. So what we're going to have is our 5' end, which still has the GTA, CGAT, CG, 3' end right there. And then we have our CGATCG, TAC, 3' right there. And now, where's our gene of interest? Right there. Okay. So those are the two molecules that you're going to generate after the first round of PCR. And then if we did a second round of PCR, now you would take these two molecules right here and denature them and anneal the primers and do it all over again. But this problem has only asked us to look at what does the molecule look like after the first round. And so that's what the answer is. I hope you guys find that helpful, and if you have any questions, please let me know.